While Spark SQL gives you a tremendous amount of power to perform arbitrary kinds of queries in SQL on data that's in Cassandra tables, it still pays to think a little bit about the structure of the Cassandra tables and the kinds of queries you're doing, because the Spark-Cassandra connector will push predicates down when possible. If a query can be done in Cassandra, it's always going to be faster than Spark doing it. If it can't be done in Cassandra, then that's fine. We should let Spark do what it does. But when it can be done, Cassandra will always do these things faster. And that's what predicate pushdown means. When you've got a where clause that has predicates in it, the Spark-Cassandra connector will push those down into Cassandra when possible and have Cassandra do that work much more efficiently than return a smaller data set up into Spark for further analysis. Let me give you a couple of examples of two kinds of predicate pushdown: clustering key pushdown and partition key pushdown. And we'll just give you a little bit of an idea how to think about these. This stuff, again, should be in your mind as you're designing your queries, because you'd like pushdown to happen if possible. Now, pushdown is enabled automatically. You have to stop it if you don't want it to be happening. But for it to work, you have to choose your tables wisely. Now, in this case, with this query, we're looking for release year and title of all of the Johnny Depp movies that were released before 2015. We could satisfy that query by actors by movie or movies by actor. Spark SQL will do both of them. Our choice is significant, though. What you should do right now is go ahead and pause the video, take a look here, and make a prediction about which one of these is going to be more efficient. To answer the question, you have to understand the Cassandra data model fairly well. If you look at the actor column in actors by movie, it's a clustering key. It's not a part of the partition key. So what Spark is going to have to do is get these results from every node in the Cassandra cluster. That's going to take a lot of work. That's not going to be an efficient query at all. Movies by actor, we see actor is the partition key, and release here is a clustering key. So both of the columns in the predicate, actor and release here, can get pushed down into Cassandra. This query can actually be satisfied as a CQL query and not even a Spark SQL query. So predicate pushdown really is our friend if we choose the table correctly. And that's a thing that we have to do when we're designing our queries. So here's an example of only the clustering key being able to be pushed. As you can see, the partition key of actors by movie, which is the table being queried here, is movie ID. And in our predicate, we only have actor and release year. So Spark will have to do a scatter gather type of query. We show this query in both forms, both the SQL version and the language integrated version. But in both cases, it produces basically the same results and does it not very efficiently. So this would be considered an anti-pattern if we had a better table available to satisfy this same query. And so we do in the table movies by actor, where actor is the partition key. That means both of the predicate columns, actor and release here, are both pushed down to Cassandra, and Cassandra has a good query that satisfies the partition key and one of its clustering keys. You'll notice compared to the last slide, we don't specify any ordering here because we know, looking at our schema, that release here is a clustering key, and we'll see results ordered by release here, whether we want them to be or not. So it pays to know something about your Cassandra schema and know something about the Cassandra data model when you're writing Spark SQL queries. The whole point of Spark SQL is that it does free you from CQL and give you access to capabilities that CQL doesn't have, but your queries will run faster if you keep your Cassandra data model in mind.